Hey, good morning, everybody. Good morning, good morning, good morning. You did a really good job this morning with your number talks. And I like the way that everybody is thinking because that's what it's all about. Remember that. Think, 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 think. I like the way everybody's thinking of different strategies that we can use for our number talks. So moving right along to today's lesson, we are going to talk about properties. Properties. That sounds kind of funny, and I don't mean houses or, someone's home or land when I talk about properties. These are math properties, which are kind of like laws. They're kind of like laws. They're specific rules that are applied to our addition and our multiplication. We do need to follow certain rules in math sometimes because if we didn't, everybody would be doing all kinds of different things and they would be getting different answers. For example, if you had an equation that had a lot of different functions in it, if you had 12 divided by 4 plus 3 minus 2, oh my goodness, everybody would probably come up with a different answer because you have a tendency to look at the numbers and the functions that you can probably do easier in your head with mental math. And then you want to do those first. And then you jump and do, oh, well, now I'll add the 2, or now I'll subtract the 3, or however you decide to do it. So to fix that problem in math, we've come up with order of operations and break it down. And it's exactly what Mrs. Smith just said. Order of operations, doing your operations or your functions in order. And yes, we do have to follow a specific order for our equations. So to help understand the why we have to do that first, it's a good idea to understand the properties of addition and multiplication, which are pretty much like laws or rules that we apply to our addition and multiplication. For example, the very first one is commutative property. Commutative property is probably the easiest one. I think it's the easiest one because all it states is that you can move numbers around and still get the same answer. For example, look at the one listed right below commutative property. It says 4 plus 3 equals 7. If I change those numbers around or swap them around, am I going to get the same answer? 4 plus 3 equals 7. Let's switch them around. 3 plus 4 equals 7. Yes, it does. You still get the same answer. So commutative property states that you can move your numbers around and still get the same answer. 5 plus 2 equals 7. 2 plus 5 equals 7. 1 plus 8 equals 9. 8 plus 1 equals 9. You can switch them around all you want. In addition and multiplication only. This does not work for subtraction and division. For example, if I change this plus sign into a multiplication sign, 4 times 3 equals 12. Does 3 times 4 equal 12? Yeah, of course it does. The commutative property states you can move your numbers around and still get the same answer. Let's look at the next one. Associative property. Associative property, when you're dealing with more than one number, in the first one, commutative property, we had 2 numbers added together. What if I add more numbers to that? And I have 3 numbers added together. 4 plus 5 plus 3 equals 12. So if I group the 5 and 3 together, do I still get the answer 12? Of course. If I change that and regroup and group the 4 and 5 instead of the 5 and 3 together, do I still get the answer 12? Of course I do. So the associative property, very similar to commutative. Commutative says you can change your numbers around. Associative property says you can regroup your numbers. You can regroup your numbers and still get the same answer. If I group these 2 numbers together, I get 12. If I group these 2 numbers together, I still get 12. And again, this works for addition and multiplication. Now, Distributive property. Distributive property, I'm going to say, is probably a little bit more difficult to understand, because when you see the actual definition of distributive property, it's kind of long and it sounds very confusing. It uses a lot of math vocabulary, but it's really kind of simple when you look at an example. So let's just look at the example under distributive property. If you think of the word distributive, you should think of the word distribute, to hand out, to give a number out to something else. You're distributing something, okay? Distributive. Look at the example. I have, first of all, two different functions in one equation. I have 3 times, and then grouped together, I have 2 plus 3. Okay, I have 2 different functions. I have a multiplication sign, and I have an addition sign inside the group. Distributive property says that I can distribute this number, the number 3 in this example, for the multiplying. If I can multiply this number by this group of numbers that I am adding together, they are add-ins, I can separate those 2 numbers. I can break this up and still multiply this number by each of those numbers individually and still get the same answer. For example, it says 3 times and then grouped together, I have 2 plus 3. Well, what if I break that group up of those add-ins and I multiply the number 3 individually by each of those? 3 times 2 and 3 times 3. And then add those 2 products together, would I get the same answer as if I added the 2 grouped numbers together and multiplied it by 3? Yes, you would. That is the distributive property. You are distributing the number that you are multiplying by. And you are just splitting up those add-ins, okay, that you are adding together. Let's look at a quick video that will help. Plus, it's a lot more fun.
Commutative, associative, distributive, all 3 math properties, yeah. Vocab, let's go. The first property is commutative. Your terms can move when you're the one computing them. If you reorder the terms when multiplying and adding, you get the same answer cause the order doesn't matter. 3 plus 5, written a different way, is 5 plus 3, they both equal 8. A plus B equals B plus A, and J times C equals C times J. Addition is not the only operation that works. We can also use multiplication, but this rule, it doesn't work with subtraction or division. With subtraction or division, stick with the order given. If you need a mnemonic, think about the root. Commutative comes from the word commute, yeah. The commutative properties, the one that allows us to write the numbers down, then move the numbers round. Okay, commutative property in any order, you can add and multiply. Associative, you could group the terms any way you like. And now the last one, when you multiply a sum, you gotta break it up. That's distributive property, it's gotta be commutative, associative, distributive, all 3 math properties. It's what you need. It's what you need. It's what you need. Associative property means when you compute several numbers, you can put them into groups. For example, 2 plus 5 plus 3, add parentheses so you can see. Place 2 plus 5 in parentheses and then add 3 at the end. Now let's begin. 2 plus 5 equals 7, and when we add 3 plus 7, the sum is 10. If we bracket the 2 numbers at the end, the answer's still 10. If we do it again with multiplication, it works the same way, but division and subtraction, they're not, they can't hang. Commutative property in any order, you can add and multiply. Associative, you could group the terms any way you like. And now the last one, when you multiply a sum, you gotta break it up. That's distributive property, it's gotta be. Commutative, associative, distributive, all three. Math properties, it's what you need. It's what you need. It's what you need. This property is distributive, and when you can use it, it's limited. Yeah. When you multiply a sum, you can multiply each adding and then add the products up. Take the problem, 2 times 5 plus 3, and the 5 plus 3's in parentheses. You can multiply the 2 times the 5, and then multiply the 2 by the 3. Alright, you get 10 plus 6, and that's 16. We distributed the 2 here. See what I mean? Here's a nice hint to make it easy to remember. To distribute means to give it to each member. Just remember, multiply each number in the bracket by the number outside. Add them up, then you have it. 8 times B plus C equals 8 times B plus 8 times C. C.
Alrighty then. All right, guys, I told you that that was definitely a lot more fun. Of course, that's because I like vocabulary quite a bit. Let me go back, and I'm going to add one more thing for today, and then I'm going to let you guys practice just a little bit on a couple of these properties for examples. Okay, I want to just add one more thing. Identity property. Identity property. If you are using an identity property with the number 1, that says that any number multiplied by 1 just keeps its identity. In other words, 12. 12 times 1 is still 12. 9 times 1 is still 9. And I think that's probably a given one. Everybody knows anything times 1 is anything, whatever that number is. So the identity property for 1 says that any number multiplied by 1 just keeps its identity. It stays what it is. Okay? And the other one is when you're dealing with 0. 0. The addition property for 0 says that a number does not change when you're adding 0 to it. And when you're multiplying, the property of 0 says that 0 times any number is equal to 0. Very simple. Okay, so those are the only 2 that I am going to go ahead and add to this. And I'm going to have you guys go practice.